Hello and welcome to the logic of it all. In this video, we will see more examples about truth tables. Here is our first example. The formula is not P or if Q then P. Now the first thing we do is we look and see how many variables are involved in the formula. In this case, there are two variables involved, P and Q. Now each variable can either be true or false. So P can be either true or false, and also Q can either be true or false, which means together there are four possible scenarios, 2 times 2. So what are these four possible scenarios? It's either that P and Q are both true, or it could be that P is true and Q is false, or P is false and Q is true, and finally it could be that P and Q are both false. Which means in terms of the truth table, our truth table is going to have 4 rows, one for each possible case. Okay, so let's start drawing the truth table, and then we talk about how to create the columns and also how to fill in the truth table. Okay, so at the moment we know that our truth table is going to have 4 rows. So the first row doesn't count because that's for the headings, but then after that there are 4 rows for the truth values. Okay, so here we go. Now, how about the columns? First of all, we need columns, one column for each variable. So I need a column for P, and also I need a column for Q. There's always a column for each variable in your truth table. Now, the final column will be representing the entire formula, but we cannot directly go from the variables to the formula. We have to build our way up to that entire formula. In particular, to be able to know the truth value of this entire thing, I need to know the truth value of not P. So I need another column for the sub-formula not P. Also, to be able to know the truth value of the entire formula, I need to know the truth value of this implication. That's another sub-formula. If Q, then P. So I need another column for that. And then, if I know the truth value of not P, and also the truth value of if Q, then P, then the only thing that I need to do is to combine them with a disjunction. So now I'm ready to compute the truth value of the entire formula. So that will be my last column. Okay? So now this is the truth table. Now we need to talk about how we can fill it in. Okay? Now if you remember again, we said there are 4 possible scenarios for the combination of P and Q. They're both true, P is true, Q is false, the other way around, and also they're both false. Now you can just randomly fill out these 4 cases here, but when we get to 3 variables or even more, it's easy to repeat a case twice in the table or miss one of the cases and so on. So there is a system for filling out these truth values for the variables that guarantees that you don't miss out a case, and also you don't repeat a case more than once. And the system is, for the first column, we fill out half of it with true and then half of the rows with false. So in this case, true, true, false, false. Then for the second column, here we have 2 trues and 2 false. We divide that into 2. So instead of 2 trues and 2 false, we alternate 1 true, 1 false, 1 true, 1 false. Now we can see that all 4 possible cases are covered. Now in the next example, when we have 3 variables, you will see the advantage of using this method more clearly. Okay, now that we have the truth value of our variables, we can build the truth value of the sub-formulas and get to the truth value of the entire formula. So let's start with the next column, which is for not P. Using the definition of the negation, not, we know that whatever the truth value of P is, the truth value for not P will be the opposite of that. So when P is true, not P is false. And again, P is true, so not P is false. And then in the last 2 rows, when P is false, not P will be true. Next column is implication. Again, you need to remember the rule for implication from previous videos. And the rule is an implication is always true except for the case where the premise, which is Q in this case, is true and the conclusion, which is P, is false. So let's go through the rows one by one and evaluate the truth value of our implication. On the first row, the premise, which is Q, is true and the conclusion, which is P, is also true. So if true, then true is true. On the next row, the premise, which is Q, is false and the conclusion, which is P, is true. So if false, then true. That's also true. And then on the next row, our premise, which is P, is our premise, which is Q, is true, but our conclusion, which is P, is false. So if true, then false. That's the only case where an implication is false. And finally, on the last row, our premise is false and our conclusion is also false. So if false, then false is true. Okay, so there is that. Now we are ready to complete the truth table by evaluating the truth value of our actual formula, which is not P or if Q, then P. Now this is a disjunction, and to know the value of the truth value of a disjunction, we need to know the truth value of the left side and the right side, but we already know that by looking at this column and this column, right? So, and for disjunction, we know that the disjunction is true if at least one of the left side or right side is true. So false or true is true, false or true is true, true or false is true, and finally true or true is true. So there you go. That's the truth table for this formula. And again, if you remember from previous videos, you know that when we draw the truth table for a formula and the column representing that formula is always true, then that formula has a name, and that's called that's what we call a tautology. So we can see from this truth table that our formula, not P or if Q, then P, is actually a tautology. So yeah, here's the truth table in a nicer format for you. And as I said, in the next example, we are going to look at a formula with 3 variables. So as you can see, we have P, Q, and R. Now again, the first step is we know that we have 3 variables, so how many rows do we need? Okay, so P can be either true or false, Q can be true or false, and R can be also true or false. So 2 possibilities for each one of them. So 2 times 2 times 2, 8 possible scenarios for the combination of P, Q, and R. You can write them down. I will do that in the table, but you start by saying all 3 can be true. It could be that P and Q are true and R is false, and P is true, Q is false, and R is true, and so on and so forth. Okay, so the bottom line is, besides the heading, the row representing the names, we need 8 more rows in our table. Okay, so this is for the name of the subformulas, and then on top of that, I need 8 more rows. Okay, it's not going to look very nice, but that's all right. So here are the 8 rows. And if you remember, I said that we always need columns, 1 for each variable. So I need a column for P, I need a column for Q, and also I need a column for R. Okay, and then we need to build our way up to the entire formula. So the first thing that we notice is that I need a column for not P, because that's a subformula. And I need not P to be able to create this entire thing. So I need a column for that, not P and R. Then I also need not Q. So here's a column for not Q. Then I need a column for not Q or P. Now finally, when I have a column for not P and R right here, and also a column for not Q or P here, then I can combine them with the rule for implication. So now I'm ready for the entire formula, which is not P and R implies not Q or P. So that's my entire table. Now we need to fill it out with truth values. We start with the variables, of course. So we have 8 rows representing 8 possible situations. If you remember, the method was for the first variable, we divide the rows into 2 halves. The first half, which is 4 trues, and then 4 falses. So half and half for the first variable. Now, we alternated between 4 trues and 4 falses. For the next one, we divided into 2. So 2 trues followed by 2 falses. Again, 2 trues followed by 2 falses. And finally, for the last one, we even divided by half. So instead of 2 trues and 2 falses, we do 1 true, 1 false, 1 true, 1 false. So we alternate between true and false for the last variable. Now, I leave that to you to check, but you can see that on these 8 rows, we cover all possible scenarios. So 3 trues and 3 falses and everything in between, without repeating any case twice or missing a case. Okay, so that's the benefit of using this method that I just described. Now that I have the truth value for all my variables, I can start filling out the other columns. So not P is the opposite of P. So wherever P is true, not P is false, which means the first 4 rows. And whenever P is false, not P is true, which means the next 4 rows. Now that we have not P and R, we can combine them with conjunction. If you remember, and it's true when both left and right hand side are true and false otherwise. So we have true and false, which is false. Then we have false and false, which is also false. Then we have true and false. Again, false and false is false. True and true is true. False and true is false. True and true is true. And finally, false and true is false. So that's the truth value for not P and R. Now, the next column is not Q. The second column is Q, so it's going to be the opposite of that. So that means false, false, true, true, false, false, true, true. Then we have not Q or P. So not Q is the last column that we did. P is the first column, and we are combining them with the disjunction, which means if at least one of them is true, the disjunction is true. If both are false, disjunction is false. So the first row is true or false, which is true. The next one is true or false, again true. Then true or true, that's also true. Then true or true again, so that's also true. Then we have, for the rest of it, P is false. So false or false is false. False or false is also false. Then false or true is true. And finally, on the last row, P is false, but not Q is true. So their disjunction is true. Okay? Now we are ready for the entire formula, which is an implication. An implication of this column and this column. Okay, and again we know that an implication is true always except where the premise, which is not P and R, is true but the conclusion is false. Okay, so in the first row, on the first row, the premise is false but the conclusion is true, so that's true. Next row, same situation. Next row, again same situation. Fourth row, the premise is false, the conclusion is true, so that's again true. Then on the fifth row, we have that, as you can see here, the premise is false, but the conclusion, the premise is true, but the conclusion is false. And that's the case that we said implication is false. Then we have if false, then false, which is true. And then if true, then false, which is also true. And finally, if false, then true, which is also true. So this final column represents the truth values of the entire formula. And again, here's a nicer version, nicer representation of that same truth table.